Hello everyone and welcome back to this course on Introduction to Data Science. In the previous videos we talked about data science. We tried to define data science, link it with concepts such as data analytics, data mining and big data. Let's now look at the data pre-processing and discuss a few things that are always coming back when you're doing a data mining project and you start with data. One of the issues you always have with data are missing values. So what's the problem? Assume that you have a data set, and how is this data set originated, say? It could be, it's a data set that is the result of measurements, or maybe it's a questionnaire that people filled in. Then what you can have is you can have either bad measurements or, for example, questions that someone did not answer. So it means that you have missing values. You see one person filling in the questions of the questionnaire, but because he or she did not fill in certain questions, well, you have a blank for that. There is a missing value. Very often, if you start calculating, if, for example, you calculate very simple a mean of your data sets, you have measurements, the length of a group of persons, and you want to calculate the average length. For example, if you have grades of students, you want to calculate the average grade. If there are missing values, you cannot calculate this average or this mean. Same holds with, for example, the variance or other statistical quantities. So if you have a data set, then there are, in the pre-processing, there are two important steps if you want to handle missing values. Step one is you have to find the observations where you have missing values. Which data points contain missing values? Once you indicate the missing values, you go to step two. You have to do something with these missing values, because you cannot continue with your calculations when you do not know about the missing values. So you have to do something, either you replace or you remove the missing values. And let me illustrate how we can deal with missing values with a simple example in R. So we have here a small data set with telecom data. So we have customers of our telecom company, and for each customer, for example, here you have customer 1, you have the ID, you have the monthly charges, you have the total charges of the customer, you have a payment method, and you have here the column churn, indicating whether the customer stayed with the company or the customer moved to another company. If you look in this data set, you see that, for example, here you have NA, not available. For customer 3, we look into the column monthly charges and there is no value. Same for customer 6 and for customer 8. So if, for example, we want to calculate the average monthly charges for these customers, then we should take all these values, take the average, but because there are 3 missing values, we cannot take an average. In this video, we focus on how we can find, how we can detect the missing values in our dataset. And then in the next videos, we will explain, once you detect the missing values, how can you handle the missing values. So the illustration is in R, but you can do similar things in, for example, Python. So if we are in R, then missing values are indicated with NA, not available. Sometimes you can have NaN, not a number, meaning that you do, for example, 0 divided by 0. It's not really a missing value, but it's also a wrong value, and you also have to deal with these values, because if you have a column where you have NaN, then you still cannot calculate your average. So NaN, these are the observations or the entries for our variables that you have to spot. So we can use in R the function is.na. Because if x is a vector, for example, in our data set we could take the vector with the monthly charges, is.na will tell me for each element in the vector x, is this a missing value, yes or no, true or false. So if is.na gives me always false, it means that there are no NAs, no missing values. With is and a, I can determine whether there are missing values, yes or no. If there are missing values, I also want to know where are these missing values, which observations contain missing values and which do not. And for that I can use the which function. So is.na gives me back a vector indicating whether it's the missing value, yes or no, which tells me which of the elements in this vector with true false is a missing value. So with this command here, I can locate the missing values. It's important to know that R will only use NA as missing value. But sometimes maybe the dataset contains missing values, but they are not labeled with NA. And if a missing value is not labeled with NA, R cannot recognize that as a missing value. So for example, assume that we read the dataset with the Telecom data. Then we have the dataset here, that's what I already showed you. So the dataset, so the whole table, is stored in data. If I want to extract the column monthly charges, I have to do data $monthly charges. That gives me the column with all the monthly charges. Then I do is.na to see whether I have missing values, yes or no. And for example, the first element is false because indeed I have, for my first customer, I have a correct number for monthly charges. So there is no missing value. I have, for example, here the third value is true, it's this one. Indeed, it's a missing value. Same as here. I have here another true. I have another true, yeah, here and here. So this monthly charges contains three missing values. It's this one, and this one. And actually, it are two NAs and one NaN, but R recognizes both as missing values. If I want to know which customers have missing values for monthly charges, I use the which function, which tells me customer 3, 6, and 8, those are the ones with missing values. If you look into the Telecom dataset, you will see that n/a is also used to indicate a missing value. It could be, for example, that someone manually inputted n/a. So he or she saw, well, there's a problem with this observation, so I just put n/a to say, well, look, here is a missing value. The problem is that R does not know that you are also using n/a to indicate missing values. So if you are using the is.na and the which function to find your missing values, R will find the NA and the NaNs, but it will not find these numbers. So there are two extra steps you have to take. First of all, you have to find out, that's step one, you have to find out what are the conventions used in this dataset to indicate missing values. Is it always NA? Then it's fine. R knows that these are the missing values. But if you typed in n/a or something else, you have to tell R that you are using other things than NA as missing values. And that is step two. And in R, we can do that as follows. Assume that you want to read this telecom.txt. You use the read.table function, and you add here, you tell R, the NA strings are small na and n/a. So now R knows whenever I see small na or I see n/a, I have to interpret that as a missing value. It's not something that should be there, it is a missing value, and you need to be able to detect and change these missing values. So assume we do this, we read again the data set and store it in data, but now we add these NA strings. So we tell R what are the conventions for missing data. And then if you look into the data set, you see that here are your missing values, and they are all labeled with NA, capital letters, or with NaN, not a number. So if you now use the is.na function, R should be able to detect these missing values. So if you look back into the dataset, the monthly charges was okay. We tested that and we saw that R was able to detect all the missing values. That's fine. Let's move to the column total charges. So I use the is.na function on the column total charges. So I use the dataset data. So data contains all the different columns. I do $ total charges to only look into the column with total charges. And I try to locate my missing values. And then R can detect two missing values, 2 and 8. However, if you go back to the dataset, you will see that observation 5 is also NA. So why can R not detect observation 5 as a missing value? Well, the problem is actually simple. What you have to do is you have to check the data file outside R. So what R is doing, it will look in your data, and as long that there is no entry for a certain column and a certain observation, it will say this is a missing value. Right? For example, you have for a customer, you can see what's the ID. So in your source file, so in Excel, for example, there is a ID number, there is a number for monthly charges, but the cell for total charges is empty. In that case, if you put that data set into R, I will say that empty cell are replaced with NA capital letters, a missing value. But assume that you looked into the Excel file, you see this cell with total charges for that observation is empty, and you type into that cell, you type NA. If you then read your Excel file in R, I will say, well, there is something in the cell, and that is NA. R will consider that as a string. There is a word, NA, that is filled into that cell, so it's not a missing value. Right? There is something, there is nothing missing. So it means that we have to tell R also that if you typed NA, and I do that here, if you typed NA, also then consider this as a missing value. So in case you say, I take the data in Excel and I did not change anything about the data, well, you don't need this. But if you know that there is some, say, manual intervention, if maybe someone changed some things about the data set, and it could be that they typed in capital N, capital A to indicate a missing value, and then you have to tell R. You have to tell R if NA is typed in, it is also a missing value. It's not a string that is in that cell. And if you then do this, so you read the data, you tell R NA typed in is also a missing value, so you add this third element to your NA string. In that case, if you locate the missing values, 2, 5, and 8 are the missing values. 2 and 8 we already had, but now also 5 is labeled as a missing value. So what is now the problem with missing values? Assume I have observations of your grades. At the end of the course, I look into all of your grades and I take the average, for example, to get an idea of how well you did in this course. Of course, it can happen that there are missing values. Maybe some of you did not take the exam, so I have no value for that. Or maybe there is a value, but someone typed it in the wrong way and I had to delete that value. All right, so you can have a data set, you can have missing values, and we want to calculate something, and now we can detect the missing values. Then there is the following problem. If we keep the missing values, we cannot calculate anything. If I have missing values, I cannot calculate an average. Then maybe you say, well, just delete the missing values. And you delete, or maybe you put something else there, and then you have a number, an observation, and you can calculate. The problem there is that you are influencing the data set. You are actively changing the data set, meaning that the results you later obtain might be dependent on what you did. Maybe you have a data set with missing values, You change something, you remove all the missing values, and you calculate. But maybe someone else is looking at the same data set, but how that person is handling missing values is different from how you are doing it. And then in that case, that other person will use the same data set, handle missing values in a different way, and find different results. So if we replace or remove missing values, we are influencing the data, and that is what we want to limit. So therefore, it's very important that we understand how are our actions on handling missing values influencing the final outcome. That's what we want to investigate. So what we do, and I will summarize it in the next slide, but then in a separate video we will look into the different methods separately. We will consider different methodologies to handle missing data, because it's very hard to say, well, this is the method to handle missing data. You have different solutions for missing values, and we try to understand what is the effect, how do we influence the data set with a certain solution, and then depending on the situation, you may think, well, now I take up methodology 1 to handle missing values, but maybe in another situation it's better to take methodology 2. Let me here summarize the 3 methodologies that we will discuss. Method 1 is, I think, the simplest method, and maybe the method that you would do intuitively if you have missing values, and it is removing the missing values. You say, if I have observations where there is a problem, just I remove the problem. The advantage is that you are not changing observations, right? You are the only data that you use is data that you actually measured that is coming from the data itself. It's not something that you plugged in. So that's one of the advantages of this method 1. The drawback is that, of course, if you have lots of missing data, then you are reducing the size of your data set. If you have 100 observations and 20 contain missing values, you end up with only 80 observations. And you know that doing statistics is more reliable when you have lots of data. So it could be that if there are many missing values and you remove all these missing values, you end up with a data set that is not reliable anymore. Then, to keep the data, you can move to method 2. And method 2 says, instead of removing the missing values, let's replace the missing values with the mean of the observations that I have. So you say, well, maybe I have 80 observations that are correct, so I can calculate an average, and then for the other 20 missing values, I plug in the mean. Right? I say they behave as the average of the rest. So the good thing about this method is that if you, for example, have a data set with 100 observations, then after you replace the missing values by the mean, you end up with a data set that is still of size 100. So you do not have this effect that you reduce your data set and maybe at the end your data is not reliable anymore. The problem is that in this case you are actively changing the observations, and we will see that in the next video, has an effect on the variance. You are reducing the variance. You make the data set more predictable than it is in reality. And lastly, method 3 is trying to overcome that issue of method 2 where you change your variance. In method 3 you say, well, we have to replace the missing value, because method 1, removing the missing value, is too brute, because I'm removing data and maybe I have data that is not reliable anymore at the end. So we don't want to throw away data, but we also do not want to replace the data with a deterministic value. Now we replace it with a randomly generated value. So because we generate it randomly, we still add variance to the data set, and we do not have this problem with the variance that we have in method 2. The problem, and that I will illustrate later on, is that if there is a relation of one variable with another variable, if you then replace missing values in a random way, of course, you do not take this relationship into account. So in case you are in a multidimensional setting, you have different values, different variables, then using randomly generated values does not take into account the multidimensional structure. And that sometimes can be a problem.